Hi, Professor Zuma Adonwekpete. Welcome my viewers and students to another interesting lesson on addition, subtraction, multiplication, and division of significant figures. In our last lesson, we learned about significant figures. And if we are not privileged to watch that video, please go back to watch that video. It will help you. After watching that video, you can now come and watch this one. It will be giving you more explanation and better understanding. I want to thank all those that subscribe to my videos. I'm really elated. I'm so excited this morning. 201 persons have subscribed. And the last video got over 8.7 thousand views. Wow! I am happy. So don't fail to subscribe, like, comment, and share this video. At the end of this class, these students should be able to solve some problems on addition, subtraction, multiplication, and division of significant figures and round values effectively in significant figures. Addition of significant figures. When addition is involved, the answer should have the same number of decimal places as the limiting term. The limiting term is the number with the least decimal places. This is because the sum or difference of two quantities cannot be more precise than the quantity having the largest uncertainty. For example, if you are told to add 16.6 gram and 5.24 gram together, while using the calculator, the result will give you 21.84 gram. But it is not a correct answer while dealing with significant figures, because 16.6 gram has 3 significant figures and 1 decimal place. 5.24 gram has 3 significant figures and 2 decimal places. So you will find out the value with the limiting term. That is the value with the less decimal point. From these two values, 16.6 gram has the value with the less decimal point, and it is 1 decimal point. As you have this value, your answer must appear, your whole answer must appear to 1 decimal place. So when we add these two together, we will have 21.84 gram. But that cannot be your correct answer. Your correct answer will be 21.8, because 4 is not up to 5. We'll discard it. So the correct answer for this question is 21.8. You have another value. Add 163.12 and 6.035 and 0.6134. These values, when we look at it critically, we will have 163.12 here has 5 significant figures and 2 places of decimal. 6.035 here has 4 significant figures and 3 places of decimal. 0.6132 has 4 significant figures and 4 places of decimal. Then you will ask yourself, which one is the value with the least limiting figure? It is 163.12, as it has only 2 places of decimal. So you will know that your answer should appear to 2 places of decimal. When you add these values together, you will have 169.7682. Your answer cannot appear like this. You have already known that your answer should appear into 2 places of decimal, and the 2 places of decimal should be 76. Then you will consider the 8th value. The 8th value here is greater than 5. So this 8 now, you will become 1 as you round it up. You round it up to 1 and add that 1 to this 6. It becomes 169.77. And that should be your correct value, 169.77. Addition of significant figures continues. We are told to determine the combined molecular mass of glucose molecule 180.156 gram per mole, and a maltose molecule 342.3 gram per mole. For the glucose molecule, 180.156 gram per mole, it has 6 significant figures and 3 places of decimal. And the maltose molecule, 342.3 grams per mole, has 4 significant figures and 1 place of decimal. If we add both values together, we will have 522.456 grams per mole, which is having 6 significant figures and 3 places of decimal. And that cannot be our correct answer because our limiting value here, it has 1 place of decimal. So our correct answer will appear to 1 place of decimal. We know that 5 here is high. So we round up this 5 now to 1. And then when we add it to this 4, it will become 5. So the correct answer will be 522.5 grams per mole. So to add 94.00 and 16 and 173.011. We'll have 94.00 that has 4 significant figures and 2 places of decimal. We'll have 16. It does not have any decimal point, but it has 2 significant figures. And we'll have 173.011 that has 6 significant figures and 3 places of decimal. You ask yourself now, which one is the limiting value? We know that 16 will be our limiting value. So that tells us that our answer will appear as a whole number. So if we add all together, we'll have 283.011, and that cannot be our final answer. Our final answer appearing as a whole number, 0 here is not up to 5, so will be rejected. So the final answer will be 283. Subtraction of significant figures. When subtraction is involved, the answer should have the same number of decimal places as the limiting term. The limiting term is the number with the least decimal places. This is because the sum or difference of two quantities cannot be more precise than the quantity having the largest uncertainty. For example, you're told to subtract 4.3542 grams from 2.12 grams. 4.3542 grams has 5 significant figures and 4 places of decimal, while 2.12 grams has 3 significant figures and 2 places of decimal. This is the limiting term because it just has 2 places of decimal. That tells you that your answer must appear to 2 places of decimal. If we subtract these two values, we will have 2.1342 grams. But your answer cannot appear like this. Remember that it has 2 places of decimal. So your correct answer will be 2.13 grams to 2 places of decimal. Subtract 5.3582 grams from 2.14 grams. 5.3582 grams minus 2.14 grams. If we subtract them, we have 3.2182 grams, but that cannot be our answer. We will look at it because 2.14 grams has 2 places of decimal, and that is the limiting value. Our answer will come back and look at it. 3.21, the decimal point should end here. But 8 is higher than 5. So we'll round it up to 1 and add to this 1. And our correct answer will be 3.22 grams to 2 places of decimal. Multiplication of significant figures. In multiplication of significant figures, the rule is to count the number of significant figures in each number being multiplied and then limit the significant figure in the answer to the lowest count. If you are told to multiply 13.012 times 21.12 times 30.0954, let's count the significant figures. 13.012 has 5 significant figures. 21.12 has 4 significant figures. And 30.0954 has 6 significant figures. Remember, we said that you are going to limit your answer to the least significant figure, which is 21.12 having 4 significant figures from these multiplications? The answer is 8270.620402176. You know, 8270.6204022176. The answer is long. You should know what you will do. You limit it to the least significant figure from given in your multiplication. So, and it is 4. So our answer now, if we look at this, the least significant should end here. But it cannot end at 0 because 6, the next value, is greater than 5. So we'll round it up. When we round up, the correct answer will now be 8271. We have another one. If we are told to multiply 12.6 times 2.4, 12.6 times 2.4, if you calculate, you have 30.24, but it's not the correct answer when you are dealing with significant figures. You know that in this value 2.4, it has only one decimal place. And in this value 12.6, it has only one decimal place. So your answer will also be to one decimal place. So the correct answer now to one decimal place will be 30.2, which is 30.2. That is the correct answer. 200 times 3.57. You must always find out which has the least significant figure. Remember, we said that zeros on the right are not significant, except they are placed in notation. So in this value 200, that's only one significant figure. And 3.57 has 3 significant figures and 2 places of decimal. Since this is having one significant figure, your answer will appear to a position of one significant figure. Always note that. So the correct answer now, when you multiply it, you will have 714, which is not correct. You look at the 714. To you, it may be correct, but it's not correct because 714 has 3 significant figures. On your own, you need one significant figure. So you will reduce all this to 0, 0, and the correct answer will be 700. That is the tricky part in multiplication here. Division of significant figures. When dividing 2 or more numbers, count the significant figures in each of the original numbers. Take the smallest of the numbers or significant figures. The product or quotient will have that minimum number of significant figures. Always note that. They say divide 14580 kilogram by 5.81 liters. So you already should apply your values or your units. Your unit should be represented in that division. So we are dividing 14580 kilogram, which has 5 significant figures, by 5.81 liters, which has 3 significant figures. When we divide it, we will have 2509 kilogram per liter. But that cannot be our answer because here now, the least significant figures is 3. But your answer is now appearing as 4 significant figures. So you will reduce this to 3 significant figures, and your answer will be 251 kilogram per liter. That's the correct answer. Divide 137.2 by 11.8. We are dividing, but remember to know the significant figures. 137.2, 4 significant figures. 11.8, 3 significant figures. So your answer will appear always to the least place of significant figures, and that is when you divide, you have 11.6721186440067. That is too much. You ask yourself, which is the least place of significant figures? The least place of significant figure is 6. But it has a 7 on that 4th position. So you round up to and add 1 here. So your correct answer will now be 11.7 to 3 significant figures. I believe that you are following the lesson on significant figures. We are looking again at rounded off values to 1, 2, or 3 significant figures. Assuming you're told to round off 25.17 to 1, 2, or 3 significant figures. 25.17 here to one significant figure, that means your value should end here, the position of 2. 5 is big enough to be rounded off. So you round it off as 1 and you add it to these 2, and then you will now have 3. Your answer should be 30. If it appears at 30, you have only one significant figure because 0 to the right are not always significant. That is the tricky part now when it comes to rounding off of numbers. We must note it. Round off 25.17 to 2 significant figures. 2 significant figures is just this 25. 1 is too small, so we discard it. So the correct answer will be 25. Round off 25.17 to 3 significant figures. 3 significant figures should end at the position of 1. But we know that 7 is bigger than 5, so we round it up. So our correct answer to 3 significant figures will be 25.2. If you are told to round off 99.98 to 3 significant figures, 99.98 here has 4 significant figures. So you are rounding off all this to 3 significant figures. So you will see this 8 now, you round it off, it becomes 10, you add 0, you put 1 here, become 10, you put 1 here, and the answer will become 100 dot. Don't forget to put this 100 dot, because without the dot, it cannot be 3 significant figures. It is the dot that makes it to be 3 significant figures. Or you can put your answer as a notation, 1.00 times 10 raised to power 2, rounding off to 3 significant figures. Assignment: add 235.67 plus 22 plus 102.34. Divide 5,003 by 3.782. Multiply 0.00004 by 725. Then round off 26.16 to 1, 2, and 3 significant figures. Thank you for being patient. In this class, I'm really grateful, and I thank you for watching to the end. Don't fail to subscribe, like, comment, and share this video with your friends and your loved ones. Parents, share it with your children. They need it. Thank you, as we expect to see my next video still on statistical measurement, treatment of the mean, mode, and median. Thank you very much.